All right, we're going to be starting Chapter 6 here today. This lesson itself is relatively simple. There are a couple pieces to this that can be a little bit confusing. What we're going to be looking at is we're going to be looking at performing operations on functions. Okay, when we talk about functions, we're talking about two different equations. So for example, equation f of x might be 2x, and equation g of x might be x plus 5. Now, in math, when we talk about operations, typically we think of addition, subtraction, multiplication, and division. We're going to be doing those four things, but we're going to be adding a fifth operation to our list, and that operation is going to be called composition. Okay, and that's a little piece that could be a little tricky here today. Now, one thing that I just want to mention to you is when you see this notation that's asking you to add, subtract, multiply, or divide two functions, I don't want you to get confused by this, what looks like an extra x that's sticking out along the right-hand side. I mean, we obviously know this is an addition symbol, subtraction. We're using a closed-in dot for multiplication, and then we know that fractions represent division. But this extra x that you see off to the side is not telling you that you are then to distribute an x into these answers. It's simply telling you that equations f and g are comprised of the variable x, okay? So, you know, in a lot of ways it might even feel like you're not doing anything with this x. So this just simply means add the two functions together, subtract g from f, multiply the two together, and then divide the two together, making sure that your denominator is never equal to 0. Okay, so if we were going to do that on just these four examples right here, and we're going to use f of x to be 2x and g of x to be negative x plus 5, it would look something like this. Okay, we're going to say that f plus g, and then we're going to put a little x here, which just means that those functions are comprised of x's, and you're simply just going to add the two functions together. Okay, now initially we might put those in parentheses, but we know that when we're adding these together, the parentheses technically do not serve a purpose, so we can just say 2x minus an x would be x, and then we'll have this extra plus 5 here. Okay, so the answer for this is that when we add the two functions together, we get x plus 5. Okay, now it becomes a little more relevant when you're subtracting two functions that you absolutely put them in parentheses, because when there's subtraction in the middle here, we need to make sure that we are distributing that subtraction sign to all the terms in the second set of parentheses. So that would make this 2x plus x minus 5, and then when we combine the like terms, looks like our answer to this is going to be 3x minus 5. Okay, so this seems simple enough here, how we're doing this. When we multiply, we're using a big closed-in dot to represent multiplication. Here we would be multiplying the 2x times the negative x plus 5. Okay, this is the situation where we would be distributing the 2x. We would get negative 2x squared plus 10x. That would be the answer for multiplying them. And then really, the easiest one of all of these is the division, because all that you're doing is you're just simply going to stack them, function f in the top, function g in the bottom. So function f is 2x, function g is in the bottom. Now you do have the added thing that you have to list your domain restriction. Okay, your domain restriction is going to be off to the side. You're going to take your denominator and you're going to say, I'm not allowed to let the denominator of a fraction equal 0. So you can see our denominator was negative x plus 5. I'm saying it's not allowed to equal 0. And then I would simply solve this equation for x. I'm going to divide both sides by negative 1, and then I have my domain restriction, which I'm going to list alongside my answer here. So essentially, we are saying that f divided by g is the fraction 2x divided by negative x plus 5, but x is not allowed to equal the number 5. If we plugged a 5 in for the x, that would produce a 0 in the denominator, which we're not allowed to have. Okay, so that's basically what we're doing. We're going to add composition to the list here. You can see at the bottom, I have 4 different examples, and in each of these examples there's an addition example, subtraction, multiplication, division. I did the addition and the division one for you. I'm just going to draw your attention here to this division one. You'll notice that our two equations are listed up here in the directions, function f and function g here. Okay, all we basically did is we divided f by g, but notice I also listed my domain restriction, which it comments about that up here in the directions. It says indicate any restrictions on the domain. If you want to make this note to yourself that that's really only going to apply to division. Okay, that's only applies to division problems. You have this added step of taking the denominator, saying that's not allowed to equal 0, get the x by itself, and that is your restriction or your exclusion. Okay, so I'm going to go ahead and run through the subtraction and the multiplication, and then we'll take a look at composition here. Okay, so what we're doing for our subtraction, okay, we write it like this. Keep in mind that extra x is just telling you that those are the variables in these functions. It does not imply multiplication. Okay, so we're going to set this up with the parentheses. Okay, here's where it's a little bit more relevant that we have the parentheses here, because we're going to be distributing that subtraction sign to the second set of parentheses here. Okay, that's going to flip the signs, make this a plus 4. And then we're just going to go through and we're going to combine like terms, like the 7x and the minus 4x are like terms, the 12 and the 4 are like terms. So I'm just going to rearrange this so it's nicely in descending order and label this f minus g is x squared plus 4x plus 16. Okay, let's try one more where we are multiplying these together. Okay, again with the parentheses, we want to definitely include these in parentheses. We're going to place them side by side now, and we would distribute the x squared to every term. So that's going to make this 3x cubed minus 4x squared. Okay, then we're going to double back and distribute the 7 to everything. That'll be a 21x squared minus 28x. And then our last thing is to distribute the 12. We get 36x minus 48. Okay, again, we want to go through, we want to combine anything that are like terms. I believe those are the things that we could combine together. I'm going to label this f times g, and we get 3x squared plus 17x plus 8x minus 48 as our answer. Okay. We're going to spend most of our time here, though, looking at composition. Whether you guys realize it or not, you actually know a little bit about composition already. Before we break down sort of what the symbol looks like here, I want you to look at just example A, because this is an example of composition in its simplest form. Okay, I think that you guys all are relatively comfortable with the idea of if a problem asks you to calculate f of -1, that is simply asking you to compose function f of a -1. Or in other words, we are plugging a -1 in for all the x's in our function. Okay, you probably heard the word composition maybe in the musical context, when a musical composer composes a piece of music. It means he is building in all of these different elements into one piece of music. Well, in math, when we talk about composition, we are talking about taking whatever's in the parentheses here. Okay, I'm going to go ahead and highlight. In this case, it was a -1, and we would be substituting that in, building that in for all the x's in our function. Okay, well, with composition, what you're doing is you're taking one equation and you're building that one equation into another equation for all of the x's. And so the one thing that you want to make sure that you're comfortable with is the notation for composition is an open circle. We said on the front, when that dot is closed in, that is multiplication. But if you see it open like that, that implies composition. And so one of the things that I like to do at the beginning of these composition problems is I like to kind of smash everything together and essentially rewrite the problem like this. Okay, now the proper way to read this is to say f of g of x. And I think what makes composition a little bit tricky for some students is it works in an unnatural way. We are used to, when we read a sentence, we always start on the left-hand side and we work our way from left to right as we read. Okay? But the way composition works is you actually start on the inside of the function. Okay? You work to the right, and you take what's on the right and you plug it into the equation that's on the left. And if you look at example A, that's actually what we did. We had to look all the way over here on the right at the -1, and essentially we were saying, let's substitute a -1 into equation F for all of the x's. Well, what this is saying is, let's take equation G and substitute into equation F for all the x's. So let's see if we can walk through an example of this here. First thing I'm going to do is I'm going to rewrite this with everything sort of smashed together. Okay. The next thing I'd like for you to do is I'd like for you to take from the right, take that g of x symbol. I'd like you to remove that symbol g of x and come up to the directions and find what g of x is equal to. You can see here it's equal to a 4x plus 5. So I want you to substitute 4x plus 5 in place of where this g of x symbol is. Okay, so we're just swapping the symbol g of x out for a 4x plus 5. All right, now I want you to treat this notation the same way that we treated the notation when we saw f of -1. Okay, keep in mind, we're taking what is on the right, 4x plus 5, and we are substituting it into equation F for all the x's. So I like to write out equation F, but every place that you see an x, you're going to place maybe a larger set of parentheses, because what we're going to be substituting in is something a little larger than just a -1. Okay? You'll notice what I have written here is function f, but parentheses where the x's are. Okay, now in for those parentheses, you're going to substitute a 4x plus 5 in for each of those. Okay, now here's where we're going to have to be careful. We're going to be extremely careful anytime we're squaring a quantity. You see addition or subtraction inside your parentheses, you are not allowed to distribute your exponent and make that a 16x squared plus 25. Okay, what we're going to have to do is we're going to have to write out the 4x plus 5 2 times on our paper. Okay, and eventually we're going to need to go back and FOIL that. But I'm going to go ahead and distribute this 3 that we have here. That'll make this a 12x plus 15 plus the 10. And then let's go ahead and double back, and we'll actually do the foiling here from writing this quantity out twice. So we get 16x squared plus 20x plus another 20x plus 25. And then I'm just copying down this extra stuff here. I might go ahead and combine these two constants at the end to make that a 25. Okay, let's underline things here that we could combine together. These are our like terms. We have 16x squared comes out to be 52x plus 50, and I'm going to label that f of 4x plus 5. So essentially what we did is we took equation G and we substituted equation G into equation F for all the x's. Whatever's on the right gets plugged into the equation on the left. Again, it works from right to left, which is a little bit unnatural here. Okay, let's go ahead and try one more example. We're going to look at example C, and then we'll take this just a slightly different direction with a couple examples at the bottom here. Okay, first thing I want you to do is I want you to take that notation, and I want you to rewrite it with everything smashed together. We're going to call this G of f of x. You'll notice the letters are in a different order here. Okay, we're going to start on the right side with the symbol f of x. We want to swap out the symbol f of x for, in the directions, what the equation for f of x equals. Looks like that equals an x squared plus 3x plus 10. Okay, I'm going to slide this over a little bit more on this side here. Whoops, I took that g with me here. Okay, so this would be our next step. Excuse me. All right, now, remember how this works. Whatever's in the parentheses, you're working from right to left. This x squared plus 3x plus 10, I'm going to substitute that whole trinomial into equation G. So I look up here in the directions. I'm substituting this into equation G right there where you see an x. Okay, so I'm going to write out equation G. I'm going to need to put a really large set of parentheses where the x is located. And inside those parentheses, I'm going to substitute x squared plus 3x plus 10. Okay, once I have made that substitution, and so it's essentially this is going into that equation for all the x's. Once you have made that substitution, you can go ahead and just simplify what we have here. I'm going to distribute a 4. Okay, don't forget about this extra plus 5 that I have here. And then I'm going to combine those together for an answer of 4x squared plus 12x plus 45. And that's just going to get labeled g of x squared plus 3x plus 10. Okay? All right. And now for a couple problems here at the bottom. Okay, I'm going to leave this visible at the top because it requires us to be able to look at equation F and equation G up here in the directions. Okay, we're not going to be doing these two problems here, but I want to apply this. These will be the last 3 problems we're going to do. We will not do this word problem here at the bottom. Okay, now what you'll notice is a little bit different about these problems is instead of an x being in this set of parentheses, you see numbers, and I guess over here there is an a. Okay, I want you to still think the way that these work is these work from right to left. That is the direction. You're starting on the right and you're working your way backwards to the left. Okay, so if we look at the right, what we essentially have here is we have the symbol f of 2. Okay, and so for problems like this, I'd like you to just calculate only what f of 2 would be. So look up here in the directions. You can see that equation f is x squared. So f of 2 would be to substitute a 2 into equation f for all the x's. We can see that what we get back out for f of 2 is a 4. Okay, now you see how I highlighted f of 2 in yellow here? Okay, so if we know that f of 2 is a 4, what I'm going to do next is I'm going to replace that f of 2 with the number 4. Okay, this is basically a 2-step problem. Now if I look at my problem is asking me to calculate g of 4. Well, now I'm going to shift up here and find equation g, and I'm going to substitute a 4 in for that x. Okay, so this is going to be 2 times 4. My official answer then is 8. I'll go ahead and just label it the same way the original problem was. So essentially what's happening here is you're going to take a 2, dump that into equation f. Once you get that answer, then you're going to dump that number into equation g. Okay, so let's try another one here. Okay, we're going to start on the inside here. This is f of 4, but we're going to start all the way on the right. We're just going to focus on finding f of 4. Okay, so again, I look up in the directions, I substitute a 4 in for the x, I get a 16 back out, so I'm going to replace this first f of 4 with a 16. I still have an f to the left of it. Okay, that's this f right here. Okay, so now this is asking me to do f of 16. So I go back, I plug 16 now into function f for all the x's. 16 squared is 256. I'll label this the original way. f of 4 is 256. Okay, all right, last one. We'll start all the way to the right. Now this is asking us to substitute a 5a into function f. Okay, so for f of 5a, you would put an empty set of parentheses where the x is in function f, and you're going to substitute a 5a in for that x. So I'm plugging 5a in here. Now, here I'm not squaring a quantity. This is everything in the parentheses is being multiplied together. In this situation, it is okay to distribute the exponent. 5 squared would be 25. A squared would be a squared. Okay, now I'm going to take this 25a squared. I'm going to replace f of 5a with that. So now I'm finding g of 5a squared. Okay, so I'm going to write out equation g, substitute a 5a squared in for the x. Okay, this is just multiplying 2 and 25 together is all this is. Okay, you're not distributing a 2 to both these things because this is not a quantity. This is just 50a squared. I'm going to label this the original way, which would be pronounced g of f of 5a. And this is the answer, 50a squared. Okay, the homework assignment that goes with this video is 6.1a.